Good evening, and welcome to the Song of Urania, a podcast about the history of astronomy from antiquity to the present, with new episodes every full moon. My name is Joe Antonini. Over the past half year, we've been getting to know the various ancient Greek natural philosophers who are rather scandalously lumped together as the pre-Socratics. And we're now very close to rounding them all out. But in the overall arc of the development of this natural philosophy, we had a real shocker in the last episode. Up until Empedocles and Anaxagoras, the natural philosophers all operated under the broad framework of monism. That is, they believed that, despite appearances to the contrary, all matter was fundamentally the same, or at least had its origin in the same thing. This overall framework then naturally presented to philosophers of the age two fundamental problems which needed to be solved. Firstly, what is that substance? And secondly, how does that substance produce the matter we see in the universe? Because we do see that things are not all the same. There are a lot of different kinds of matter. There's air, there's water, there's rock, and metal and fire. How does a single substance manifest itself in such a way that it becomes all the diversity of matter in the universe? But after the efforts of a succession of the most brilliant natural philosophers of the day, from Thales, who you'll recall was so famous that plebeians were graffitiing his name in public lavatories centuries later, to Pythagoras, who generated a cult-like following that persisted for centuries, to Zeno, whose paradoxes are still discussed to this day, it seemed that after all of the efforts of these brilliant philosophers, no one was any closer to definitively answering either of these questions. Each philosopher had his own unique preference for what the fundamental substance was, and none of the explanations were very convincing for how that substance produced the manifold diversity of the matter we see around us. By the time we arrive at the Eleatic school, we see that Parmenides has taken monism to its logical conclusion. All things are indeed one, and anything that says anything to the contrary, like for example your senses, is deceiving you. But in the last episode, this paradigm of monism was completely upended by two philosophers, Empedocles, who broke from monism in a seemingly tentative way by saying that there were four fundamental elements, earth, fire, water, and air, but conceptually was a huge break from monism. And then Anaxagoras, who broke from monism in a more quantitatively substantial way by arguing that there were myriads of fundamental elements and that every bit of matter contained all of them, just in different proportions. Now, some listeners may be a little bit disgruntled that I have been spending so much time over the past several episodes on this monism-pluralism distinction. After all, this just concerns the nature of matter, and isn't that just plain old physics or chemistry? This is nominally a podcast about the history of astronomy. What do these ideas about the nature of matter have to do with astronomy? With apologies to Tertullian, we might ask, what has Miletus to do with Greenwich? Well, I would like to ensure that all of my listeners are fully gruntled. To take this question on its face, of course, one of the central problems of astronomy is that of cosmogony. We see the heavens above us, the stars, sun, moon, and planets. How did they all come to be? What are they made of? Are they made of the same things as we have on Earth? All these are astronomical questions and need an answer to the question of what the fundamental nature of matter is. If all things are of a single substance, when the universe was formed, how did a multiplicity of substances come to be? How did the sun and the moon come to be and be different from the Earth? But to take this question of why I've been dwelling on the monism-pluralism distinction at a somewhat deeper level, you may recall all the way back to the first episode when I tried to outline some of my goals in this podcast. One of these was to take the astronomers of history holistically and on their own terms, and not try to pick out bits and pieces of their philosophy that happen to neatly fall into our modern categories of astronomy. The people of this era who had the most to say about astronomy were the natural philosophers we've been talking about, and they were intensely interested in the fundamental nature of matter, so it is something we ought to consider carefully when talking about them. And we should do this not just out of a sense of a sort of intellectual respect, but These sorts of philosophical ideas in many ways motivated the approach they took to answering astronomical questions. And not just the approach they took to answering these questions, but these philosophical foundations were what determined what questions they thought to ask. This idea of monism is a good example of what the philosopher of science Thomas Kuhn called a scientific paradigm. It was a sort of background assumption that pervaded and directed the work of the scientists of the time. In this case, the more or less unstated assumption was that there should be only a single kind of substance that makes up all matter, and this naturally led the great philosophers of the day to those two all-important questions: what was that substance, and how did it produce the great variety of things that we see? Because they were working within a monist paradigm, it was essentially guaranteed that these philosophers would spend most of their energies answering those two questions. But in Kuhn's theory of scientific inquiry, as scientists continue working within a paradigm, they accumulate results which are in tension with each other, and eventually it becomes apparent that they are in tension with the paradigm itself. Then a breaking point arrives, and at some point the paradigm itself has to be discarded and a new one established. We can see how the development of Greek natural philosophy from monism to pluralism fits rather neatly into this pattern. Over time, various philosophers had argued in favor of different elements as being the arche, the fundamental substance, and they had made arguments for their own view. But they couldn't all be right. If Thales was correct that the arche was water, then necessarily anyone who said that it was anything else was wrong. And that was, after all, everyone else. So no matter how persuasive their reasoning was, they could not all be right. And in its limit, Parmenides, along with his student Zeno, had made very compelling arguments that not only were all things one, but that this implied that motion itself was impossible. The paradigm of monism had reached a breaking point, and new philosophers had to step in and propose another paradigm. Now, the way I've told this story to you is rather pat, and I doubt that any of the philosophers involved in this story were thinking about monism or paradigms in quite these terms. And really, this kind of story doesn't fit exactly into Kuhn's structure of science, because in Kuhn's conception, the tension that develops within a scientific paradigm generally has more to do with observations or experiments whose results conflict with theory, or at any rate are very difficult to explain within the existing paradigm. But at this stage of Greek natural philosophy, there's very little in the way of observation or experimentation. I had mentioned 2 episodes ago how Xenophanes had pointed to the existence of fossils of seashells up in mountains as evidence that water must have covered the earth at one point. But the reason I had mentioned it was because it was the exception and not the rule. The only real observation that was in tension with the monist paradigm was just the simple fact that there are different kinds of things in the world. Nevertheless, that one observation was enough to cause all sorts of trouble for monism. Well, the point of all this is that I have been spending quite a lot of time on the monism-pluralism distinction, because these paradigms informed how the natural philosophers approached their astronomy. Any monist theory of the world had to explain how the variety of matter in the world came about from the one fundamental substance, and this meant that they had to develop a theory of how the entire universe began, both the earth and the heavens. This then meant that they had to say something about what the heavens were made of. Today, of course, we naturally think that astronomy should say something about what the stars are made of, but that is just because it's a question that naturally fits into the modern paradigm of astrophysics. Depending on your paradigm, it is not necessarily an obvious question to ask. As far as we know, the Babylonians were never interested in that question, despite being intensely interested in astronomy. And later on in the early modern period to the early 1800s, we see occasional speculation about the nature of stars, but not a lot of debate about this question relative to other scientific questions of the age. It's always important to understand the philosophical underpinnings of an era, because those ideas, even though they may be largely tacit, are what direct the efforts of the scientists of the age. Okay, so we have seen how monism had some fundamental difficulties and led to a reaction by Empedocles and Anaxagoras, in which they abandoned monism and proposed pluralism instead. There was no single fundamental substance, but instead several fundamental substances. But this viewpoint also had difficulties, which two subsequent philosophers identified and tried to resolve with a new way of explaining matter. These two philosophers were Leucippus and Democritus. Now, Democritus is certainly the more famous of the two, but at least in the ancient sources, the two of them are almost inseparable. It seems that by the time the sources start to survive, it had been long enough that the authors were no longer able to distinguish between the contributions of Leucippus and Democritus. It's very rare that one is mentioned without the other. Nevertheless, as classicists are wont to do, from these few occasions they try to glean what differences they can between the two philosophers. The general conclusion from these kinds of readings is that Leucippus probably had the original idea for atomic theory, and Democritus, as his student, enthusiastically took the theory up and expanded upon it. Well, despite the fact that Leucippus and Democritus are nearly always lumped together, in this podcast I will take them one at a time. But do take heed that there is a fair amount of conjecture when saying that this or that idea is due exclusively to one or the other. Now, of the two, Leucippus was almost certainly the older one, but that's really all we can say for sure about his biographical details. Even still at this stage of Greek history, just entering the classical era, our knowledge of births and deaths can be pretty spotty. For Leucippus in particular, we have very little idea as to when he was born. We just know that he was active during the 5th century BC. He was contemporaneous with Anaxagoras, so he may have been born roughly at the beginning of the 5th century BC. He was most likely born in Miletus, which of course was still the intellectual capital of Greece around the time of his birth. Or maybe he wasn't born there. Maybe he was instead born in the city of Abdera in Thrace, which, for those of you less familiar with Greek geography, is on the coast at the northernmost part of the Aegean Sea, right where Greece sort of hooks over next to modern-day Turkey. Or maybe he was born all the way over in Italy, in Elea. Or maybe he was not born anywhere. Epicurus claims that Leucippus never even existed at all. But this may have just been due to some professional jealousy. At any rate, other writers like Aristotle and Theophrastus are quite definite that Leucippus was the originator of atomic theory. Based on the patchy and sometimes contradictory statements in the ancient literature about Leucippus's life, perhaps the most plausible reconstruction of his life was that he may have been born a little after 500 BC in Miletus. Now, you'll remember from the last episode that during the early 5th century BC, Miletus was a tumultuous time to be politically. The Greeks were expelling the Persians from the land during the Greco-Persian Wars, and by the 470s, the Greeks, or more properly an alliance of Greek city-states led by Athens, were driving the Persians out from Ionia. So by the middle of the 5th century BC, Miletus was an independent Greek city-state once again. Sort of. Over the course of the 5th century, after their victory in the Greco-Persian Wars, Athens came to grow into a place of hegemony in the region. And so while Miletus was nominally independent, it was heavily influenced by Athens at that time. In 451 or 450 BC, it seems that there was a revolt in Miletus, and the oligarchs who ruled the city attempted to break free from Athenian control. But in 450, Athens sent a garrison to Miletus to replace the oligarchs with a democratic government. Now, in this particular instance, Athens was not especially interested in making the world safe for democracy. They simply wanted to install a government that would be more amenable to their control, and naturally this democratic government would be overseen by a commission of 5 Athenian rulers called archons. At any rate, it's conjectured that Leucippus may have emigrated from Miletus during the upheaval of 450 BC. He then may have traveled to Elea, where he picked up the ideas of the Eleatics, and finally traveled to Abdera towards the end of his life. Well, I'm starting to feel somewhat unsettled with all this conjecture, so let's move to more solid ground. As for Leucippus's philosophy itself, his central idea was the one that both he and Democritus were best known for, both in his day and in our own, his theory of atoms, that all matter is composed of atoms, which by definition are indivisible, atom literally meaning uncuttable in Greek. Thus, matter cannot be divided indefinitely into smaller and smaller pieces. There are fundamental components that simply cannot be split. Now, with our modern perspective, We can see this as being a truly revolutionary idea. No less than Richard Feynman claimed that if all human knowledge were lost in a great catastrophe, except for a single idea, the idea that would carry with it the most important foundations to rebuild the edifice of modern knowledge was the fact that all matter is made of atoms. But Leucippus himself, along with Democritus, probably did not regard this as being so much of a revolution as a compromise position between monism and pluralism. It was a sort of Hegelian synthesis of these two contrasting ideas, with monism being the thesis, pluralism being the antithesis, and atomism being the synthesis. So, with the thesis of monism, we have the problem that I've been harping on endlessly now. How do you explain the great variety of matter we see with a single substance? The antithesis of pluralism then rejects the idea of monism and says that there are simply many different kinds of fundamental substances. But then this idea has its own problems, namely that it doesn't really seem to explain anything. We can see that there are patterns across different kinds of matter. We can see that water can become steam, and steam can condense into water. Surely there's some relationship between the two there. How do we explain one kind of matter turning into another? Leucippus's synthesis of atomism tries to take the advantages of both pluralism and monism and avoid the disadvantages of both. So in this theory, there are many different kinds of atoms, which is a sort of pluralism, but each atom is one single kind of substance, both in the sense of different atoms of the same kind being indistinguishable, and in the sense that each individual atom is one single object which cannot be divided, which is itself a kind of monism. Moreover, the idea of atoms also solved the vexing paradoxes of Zeno. How can you move from one point to another if you have to move first halfway there, and then halfway from that point, and halfway from that point, and so on indefinitely? If things were made of atoms, which cannot be divided, the atomic philosophers reasoned that then you can't divide things indefinitely. So the proposal of taking an infinite number of steps halfway to your destination would fail, because sooner or later, the distance to the destination would be spanned by a single atom, and you could divide it no further. So the genius of the atomic theory was that it seemed to unify the various philosophical strains of the day and solve the problems associated with all of them. But, of course, there's always a catch. Atomic theory seems to have solved a lot of problems with monism and pluralism, but it now presented some new and tricky problems of its own. And really, there were just two. What was going on inside the atoms, and what was going on outside the atoms? To start with the second, the whole idea of the theory of atoms was that all matter was composed of indivisible units called atoms. But what was it that existed between the atoms? It could not be other atoms, because then you would essentially have the same problem that Parmenides did. All the atoms are squashed right up next to each other and can't move, and so no motion is possible. Now, Empedocles, in his system of 4 elements, had argued that it was air that separates all other matter from itself and allows for motion. But of course, this won't work in an atomic theory, because the air itself has to be made of atoms, and what is separating the air atoms? So the only possible answer is that empty space separates the atoms. But this is a disconcerting position to take. We moderners are so accustomed to the idea of space as a vacuum that we don't really think twice about it, but to the ancient Greek philosophers, this was a hard concept to grasp. Because, as Parmenides persuasively argued along with a student of his by the name of Melissus, a vacuum is, by definition, nothing. And nothing is, well, nothing. It has no properties whatsoever. And of course, the most basic property that any substance can have is existence. By definition, then, the vacuum cannot exist. Well, Leucippus gets around this thorny problem with a bit of linguistic sleight of hand. Sadly, I cannot read ancient Greek, or modern Greek for that matter, so I cannot go into the details of exactly the wording that he uses. And anyway, his own words do not survive to us, so we cannot make his original distinction even if we wanted to. But in modern English, one way we could put it is that he admitted that while the vacuum is not real, in that it has no properties and cannot be touched or held, it nevertheless exists. He drew a distinction between 2 kinds of existence or reality. Only matter exists in the fullest sense. But empty space exists in one sense but not the other. Another way to put it is that the universe consists of everything that exists, and that what exists can be divided in what he called the full and the empty. The atoms are full, and the space between them is empty, defined only by the absence of matter occupying it. Now, as can often be the case when thinking about philosophy, particularly some of the ancient philosophers, it can seem like this distinction is just a game of semantics. But it is a distinction with a difference. Up until Leucippus, natural philosophers in ancient Greece equated reality with matter. If a thing existed, it must be made of something, and if something was made of matter, it must exist. But Leucippus here introduced a new conception of existence, something that could exist and yet not be made of matter. And again, not to put too fine a point on it, if we moderners find this distinction rather obvious, it's because very few of us have thought very hard about what exactly empty space is, or a true philosophical vacuum is, because these are not the same things. Now, a risk here is that Leucippus was not actually solving the problem he had set out for himself of unifying monism and pluralism, but instead just ended up as a dualist, a pluralist with two elements, atoms and space. But thanks to Leucippus's sleight of hand, he avoided this dreadful fate. Since the empty space was defined simply by the absence of matter, because it lacked the fullness of reality, it didn't exist on the same ontological level as matter did. So you couldn't argue that his system was dualist because that requires the two fundamental elements to be, like Montague's and Capulets, alike in dignity. In this case, they are not. Empty space is clearly ontologically inferior to matter. So that's the main problem that atomic theory has outside the atoms and how Leucippus solves it. What separates the atoms? Empty space. So this leaves us with the second problem that atomic theory has to answer, namely what is going on inside the atoms. After all, the main claim of atomic theory is that atoms are, by definition, indivisible. This means that they must have no parts. And yet it seems that they must also have extent. They must extend across space. If they didn't, then you would need an infinite number of infinitesimally small atoms to produce objects of finite size, in which case you're just back at the old conception of continuous, infinitely divisible matter. But how can an atom extend across space and yet have no parts? If an atom extends across space, it would have, for example, a left side and a right side. This means that there is some stuff on the left side that's not on the right side and vice versa. But this seems to imply that the atom does indeed have parts. There's a component of one part of the atom that does not belong to the other part. Now, Leucippus did not seem to view this as a problem. Sure, the atom has an extent, but so what? You still cannot pry it apart and produce a separate left half and right half of an atom. But even if Leucippus himself didn't see this as being a very strong argument, this was one of the arguments lobbed by other natural philosophers against Leucippus, Democritus, and the other atomists as to why their atomic theory had to be wrong. Okay, well, I've said a little bit about how atomic theory tried to bridge the gap between monism and pluralism, but let's go into a little more detail about that now. How exactly did these atoms produce different kinds of matter? Leucippus identifies three qualities to the atoms that produce these differences. Now, his terms for these qualities are a little strange to us. He uses the terms rhythm, touching, and turning. A more modern interpretation, rather than a literal translation of these words, would be something closer to shape, arrangement, and position. The quality of shape, which corresponds to Leucippus's literal term rhythm, refers, as you would expect, to the shape that the atom takes on. An atom in the shape of a sphere would have different properties than an atom in the shape of a cube, or a dodecahedron, or an icosahedron. Leucippus's term touching corresponds to the quality of arrangement, so different atoms can agglomerate together, and depending on which atoms are clustered together and the arrangement of this agglomeration, which one is on the left, say, and which is on the right, this can produce different kinds of macroscopic qualities. Finally, Leucippus's last quality of turning corresponds to the quality of position. So depending on how the atom is oriented in space, it can have different behaviors. To explain these different qualities, Aristotle uses an example which he probably got from Democritus. You can imagine each of the atoms as a letter. So the letter A is different from the letter B because the shapes of these two letters are different. But then you can put the letter A next to B to produce AB, or you can put it the other way around and get BA. These two arrangements could produce different macroscopic qualities. Finally, if you consider a letter like a lowercase p, this is like a lowercase d turned upside down. So by rotating the atoms, you can also get different kinds of qualities. Now, one important thing about this list of these three qualities, shape, arrangement, and position, is what is not there. Leucippus does not include some internal kind of substance. All the atoms are made up of the same thing. There is just one kind of matter. But sometimes this matter is arranged differently or sculpted into different kinds of shapes, and this produces apparently different substances. So Leucippus can maintain the essence of monism and still provide a reasonable explanation as to how we see different kinds of matter in the world and how one kind of matter can turn into another. From a modern perspective, this theory holds up remarkably well, at least in its broad contours, even if not in the specifics. Modern chemistry claims that all the matter we see around us is composed of just 94 naturally occurring, distinct elements, and by binding different combinations of elements together, we can produce the complete diversity of matter in the universe. Now, of course, a big difference from the theory of Leucippus and Democritus is that modern physics and chemistry hold that there are indeed different fundamental kinds of atoms. At one level, there are the different elements, and even if you go to the level of subatomic particles, there are individual units of matter which are fundamentally different from each other, like electrons and up quarks and photons. These particles are not different from each other because they have different shapes, but because other properties, like their mass, electric charge, lepton number, and so forth, are different. In fact, in the Standard Model, it's not even possible for elementary particles to be different in shape, because having a shape implies having an extent, and elementary particles, so far as the Standard Model is concerned, have no extent at all. So, Leucippus's explanation that atoms are different in terms of shape does not hold up so well, but his explanation that atoms in different arrangements produce different kinds of matter holds up remarkably well. What about the third quality he describes, that of rotation? Well, if we squint hard enough, we can make the argument that it does sort of hold up. One of the principal discoveries of quantum mechanics is that elementary particles have a property called spin, which is a sort of internal angular momentum. This spin can be oriented in different ways and does distinguish otherwise identical particles. So, if we're being generous and allow ourselves a bit of a stretch, we could say that this is sort of like Leucippus's quality of rotation. Now, apart from laying out these three qualities of shape, arrangement, and orientation, Leucippus does not have much to say about how exactly these different qualities produce the different kinds of matter that we see. He claims that fire is composed of spherical atoms because the spheres can slip by each other easily and produce the volatile, effervescent quality of fire. Not to get too far ahead of ourselves here, but his student Democritus has a great deal of fun, by contrast, taking this theory and elaborating upon it and explaining exactly what kinds of shapes correspond to what kinds of materials. Leucippus also claims that there are an infinite number of different kinds of atoms. In particular, atoms can come in an infinite number of possible shapes. Now, Democritus breaks with his teacher on this point. Democritus argues that this is impossible, because if atoms truly came in an infinite number of shapes, then this would mean that some shapes would have to be arbitrarily large, because you cannot have an infinite number of shapes within a finite volume. And this means that some atoms would have to be so large that they would be visible to the naked eye, and we do not see any such atoms. Now, to modern ears, this does not sound like a particularly compelling argument. At least it does not strike me as particularly compelling, because it's not obvious why you couldn't have some arbitrarily intricate shape within a finite volume. Okay, well, we've now seen much of Leucippus's atomic theory itself. What did this imply about his astronomy? Leucippus's theory of atoms mostly informs his cosmogony. In Leucippus's telling, the universe begins with the atoms dispersed throughout the void. Then, gradually, they collect into a vortex. Over time, the density at the center of the vortex increases, and the increased congestion of all the atoms trying to move past each other forces the faster moving atoms towards the outer reaches of the vortex. Leucippus identified 4 stages in the formation of the universe. So in the first stage, the vortex begins to form. Now, this initial stage actually presents some problems, because the atoms all need to start moving for the vortex to form. But what causes them to move in the first place? Leucippus does not really regard this as a problem to be solved, however. He just says that this initial motion of the atoms does not need to be explained any more than their positions need to be explained, or their existence at all. It's just how things were at the beginning of the universe. Now, as the atoms start moving around, they start bumping into each other. Now, when the atoms collide, they can either bounce off of each other or stick together. In these beginning stages, they're mostly just bouncing off of each other. But the collected sum of all these collisions is that on average, all the atoms start moving in a circular motion and forming the vortex. At this point, each individual atom is mostly just going in whatever random direction it happens to be going in, but on average, a slight rotation begins to appear. Now, in the second stage, the vortex starts to grow. The larger atoms start to stick together and fall towards the center of the vortex. The lighter atoms continue bouncing around and bounce out of the center of the vortex and end up in the outer reaches of the vortex. So during the second stage, we have bigger atoms in the middle, which is now starting to form a circular mass, and smaller atoms on the outskirts. But eventually these smaller atoms start to stick together too, and they form a membrane or shell around the inner disk. The third and fourth stages of the creation of the universe are a little more cryptic, at least in Diogenes Laertius' telling. But it seems that at the beginning of the third stage, the disk that is forming at the center of the vortex is somewhat elastic. The outer parts are rotating more quickly than the inner parts, so the whole thing is essentially a fluid, like a whirlpool, rather than a solid, like a spinning plate. But at the center of the disk, the rotation is very weak, and so the largest atoms, which are located there, can eventually resist it. So at some point, the center of the disk stops rotating, and then this provides resistance to the outer layers of the disk so that they gradually stop rotating as well. By the end of the third stage, this disk has stopped rotating entirely. In the fourth and final stage, the disk at the center of the vortex has finished developing, and you may have guessed that this becomes the Earth, and the development of the universe now takes place in this membrane or shell that appeared during the second stage. This membrane consists of the finest elements, and during this stage they now coalesce both with each other and with other atoms beyond the membrane that were not caught up in the original vortex, and become the sun, moon, stars, and planets. As they become concentrated, these fine elements ignite, which is why these various bodies shine in the sky. Leucippus's cosmogony pretty much determines his cosmology as well. This disk at the center of the universe is, of course, none other than the Earth, so the shape of the Earth is that of a short cylinder, like a drum. The sun is farthest away from the Earth because it has to move the fastest in order to burn the brightest. Then there are the stars, and closest to the Earth is the moon. Then the disk of the Earth is tilted relative to the motions of the outer membrane, which explains why the North Star is not directly overhead. Well, before we get too deep into the astronomy, let's turn to Leucippus's likely student, the more famous Democritus, because he seems to have been more involved with working out the implications of atomic theory. Democritus was quite a bit younger than Leucippus, which is why it's usually assumed that he learned from Leucippus. Although we don't have a great handle on when Leucippus was born, probably a bit after the year 500 or maybe 30 years later, we have a better idea of when Democritus was around. In fact, the writer Apollodorus of Athens wrote that Democritus was born in the 80th Olympiad. Now, you may remember from the first few episodes of the podcast that in ancient Mesopotamia, years were generally counted with respect to the reign of a king. So a tablet might date itself as being written in the 5th year of the reign of King Nebuchadnezzar. This practice was not unique to ancient Babylon, and it is quite common in monarchies. In fact, to this day, the British Parliament officially archives its acts with respect to the year in the reign of the sitting monarch, rather than with respect to the Gregorian year. But this technique did not work so well in ancient Greece for two reasons. Firstly, the city-states were largely independent of each other, and each one might be ruled by its own king or tyrant. There wasn't the same political unity in ancient Greece as there was in ancient Mesopotamia. Secondly, by the time we get into the classical era of ancient Greece, many of the city-states had adopted democracy, Athens, of course, becoming the most important among them. So now there's no king at all whose reign you can reference when specifying a year. So particularly by this point, years start getting specified with respect to the Olympiad instead. Now, the Greeks had, for centuries, gathered together at regular intervals to engage in sporting competitions. You might recall that I had mentioned in episode 9 how Thales may have announced his prediction of an eclipse at one of the Pan-Ionian Games. This was an event that involved the 12 city-states of the Ionian League, and also had a religious ritual and festivals along with being an occasion for political discussion among the elite of the 12 city-states. Well, the Pan-Ionian Games were not the only such competitions in ancient Greece. The other regions of ancient Greece had their own competitions, and the region around Sparta, a peninsula called Peloponnesia, was no different. The Greeks in this region had a competition every 4 years called the Olympic Games, because it was located at a site called Olympia, which was a sanctuary dedicated to Zeus. Records of the winners of the competitions were meticulously kept, going all the way back to the first competition, so the date of the first competition can be stated exactly: 776 BC. For the first few centuries, the Olympic Games were just a regional competition, and only athletes from the western part of Peloponnesia, just around the vicinity of Olympus, competed. But possibly because it had been around for so long, much longer than the other competitions that rose to prominence, it began to attract athletes from farther afield. A century later, the games had started to play a role in the cultural life of Sparta and its nearby frenemy, Athens, both of which were relatively nearby to Olympus, but further away than the competitors from the first 100 years. By the early 6th century, they had started to add other competitions around this 4-year cycle of the Olympics. There were the Pythian Games that came 2 years after the Olympic Games, and then the Nemean and Isthmian Games, both of which occurred every other year in between the Olympic and Pythian Games. Together, these 4 competitions came to be known as the Pan-Hellenic Games, and over time they really did live up to this name. As Athens and Sparta came to occupy a more prominent place in the larger politics of ancient Greece over the course of the Archaic Age, their athletic competitions started to become more popular throughout all of Greece. And by around 500 BC, the winners of the competitions are no longer exclusively from Athens and Sparta, but start to come from all over the Greek world. So by the time we get to the classical era, this 4-year cycle of competitions had grown to play a prominent role in Greek cultural life. Given the shortcomings of dating events with respect to the year of a king's reign, it makes sense then that instead authors came to date events with respect to the Olympiad, this 4-year cycle. Well, all of this is to say that when Apollodorus writes that Democritus was born in the 80th Olympiad, we can date that exactly to the years 460 to 457 BC. Now, Apollodorus was writing a few centuries after Democritus, so maybe his confident assertion shouldn't be blindly trusted. But this is more or less in agreement with what other authors have to say about the year Democritus was born, including Democritus himself. Democritus wrote that he was a young man when Anaxagoras was old, and given that Anaxagoras was likely born around the year 500 BC, this would have made Anaxagoras around 60 when Democritus was 20. Our knowledge of Democritus's life is much more complete than Leucippus's. He was almost certainly born in Abdera, which I've mentioned was in Thrace, close to the northernmost part of the Aegean Sea. Like pretty much all philosophers of the day, he came from a very wealthy family. There's a story that many years earlier, Democritus's father had even entertained the Persian king Xerxes during Xerxes' conquest of Greece. Later on, this story grew to include a detail that some Persian bureaucrats had remained behind in Abdera at Democritus's household and had taught the young child the secret knowledge of the Babylonians, including their astronomy, mathematics, and religion. But Xerxes' invasion was about 20 years before Democritus's birth, so this detail is almost certainly an embellishment. But the reason that this embellishment probably came about is that Democritus had a detailed knowledge of the science and religion of the Near East, and later authors wanted to explain how he had acquired this knowledge. Well, we have some strong circumstantial evidence that Democritus did in fact have a strong knowledge of the Near East. In fact, he apparently wrote a book titled On the Sacred Writings of the Babylonians, so we do have to still explain how he got it. Well, Democritus was not a firstborn child. He was the third son, so there was no social necessity for him to remain in Abdera after his father died. Once his father had died, he apparently took his inheritance and used the funds to travel widely. He likely visited Egypt and Babylon, and some accounts say that he traveled as far as Persia and even India, where he apparently conversed with what are described as, quote, naked philosophers. Democritus probably did not make it so far as India, but given the trade networks of the time, travel to Egypt or Babylon or both is pretty plausible. Throughout his life, Democritus was reputed to periodically go, quote, into the tombs, as a sort of contemplative retreat, and he had probably learned this practice from the sages of the Near East. Eventually, his travels came to an end, and he apparently returned to his hometown of Abdera, although he probably also continued to travel throughout the rest of Greece. He may have made his way at some point to Magna Graecia and learned from the Pythagoreans there, since he wrote an entire book about them. And during all his travels, he at some point visited Athens. In fact, he writes that while there, he saw none other than the great Socrates, although he was evidently too modest or starstruck to introduce himself to the great philosopher. Well, ultimately, he lived to be very old, some 90 years old in fact, or 109 in some tellings. There's a story that when he felt that it was his time to die, he refused to eat. But when he realized that he would die during a religious festival, he gave up his fast and instead ate loaf after loaf of bread, so that his sister would not have to miss the festival to mourn him. Towards the end of his life, he went blind, but said that it was no matter, because what he could see with his soul's eye was more beautiful. His optimistic character led to him being known as the laughing philosopher, in contrast to Heraclitus, whom we talked about in episode 10, whose pessimistic view of humanity earned him the nickname the weeping philosopher. Well, so much for the life of Democritus. We know that at some point he interacted with Leucippus, probably late in Leucippus's life, when he had likely moved to Democritus's hometown of Abdera. And from him, Democritus had learned of the atomic hypothesis and become an enthusiastic proponent of the idea. Quite unlike Leucippus, who wrote maybe one work, and probably not even that, Democritus was exceedingly prolific. Some 70 works are attributed to him. But, as is ever the tragedy when dealing with ancient Greek literature, virtually all of his output has been lost, except for a few fragments here and there. But, at the very least, we do have the titles of these lost works from the Roman grammarian Thrasyllus, and they give a tantalizing indication of the tremendous breadth of Democritus's interests. To give you a sampling of the topics Democritus wrote on, a few of the titles are On the Disposition of the Wise Man, On the Things in Hades, On Manliness, On the Planets, On the Senses, On Magnets, Description of the Heavens, On Verbs, On Diet, and my own favorite, Fighting in Armor. Well, Democritus is, of course, best known for atomic theory, and as I mentioned at the outset of this episode, his atomic theory is largely inseparable from that of Leucippus's. But one area where Democritus did go further than his teacher was in specifying what kinds of atoms made up various substances of the world. In particular, he argued that the heavens were all made of very round atoms, either spherical or something very close to spherical. Because of the spherical shape, these atoms could easily move past each other and were extremely volatile and were the main component of fire. This, then, is what produced the fiery appearance of the stars, moon, sun, and planets. Now, Democritus also broke with his teacher in his cosmogony. Leucippus produced an elaborate tale in which the atoms collect in a vortex and gradually coalesce into the earth and the heavens. But to Democritus, this kind of a beginning was impossible, for, in the formal Latin that the argument came to be known as, ex nihilo nihil fit, or nothing can be created from nothing. The idea is simply that if there is nothing, then it cannot create anything. This means that the universe must be eternal, because otherwise, at one point, there would have been nothing, and nothing can be created from nothing. Now, this argument was not original to Democritus. You probably won't be surprised to hear that Parmenides espoused this idea too, but even he wasn't the first. It's an ancient argument and goes back much further. But Democritus almost certainly crossed paths with Anaxagoras as well at some point in his travels, because much of his astronomy is taken from Anaxagoras, though he does change a few details here and there. In particular, Democritus claims that Venus is closer to the Earth than the Sun, so the order of the heavenly bodies from closest to Earth to farthest away goes Moon, Venus, Sun, the other planets, and then the stars. Democritus's model of the Earth is also a little unusual. Like Leucippus, he also described the Earth as being more or less flat, but with the sides a little higher than the middle, like the surface of a drum. But he didn't believe that the Earth was exactly circular. Rather, he believed that one direction was 1.5 times larger than the other, so that it was rather oval in shape. But unfortunately, nothing survives to tell us why exactly he favored this shape. One of the few unique views in Democritus's astronomy was his opinion of comets. He believed that they appeared when two planets or two stars came into conjunction with one another, so that their rays united. Well, because Democritus repeated so much of his astronomy from Anaxagoras, there's really not a lot more to say. Though one thing that's worth highlighting is that along with Anaxagoras and Leucippus, he believed that there were many worlds. This seems to have been a not uncommon belief among many of the pre-Socratics, despite the fact that nearly all of them professed a geocentric cosmology. Now, where these other worlds existed seems to have varied somewhat. Some held that the other planets were worlds much like the Earth, with plants and animals living on them. Others seemed to hold that there were simply separate solar systems, not visible to us. This seems to have been Leucippus's conception. The Earth and the heavens were created in this great vortex, but there had been other vortices elsewhere in the universe, and they had created their own worlds. Well, Leucippus and Democritus were highly influential to the philosophy of ancient Greece. Atomic theory did not die out with them, but persisted in its own school, though none of its other members enjoyed anywhere near the fame of its founders. But one student of the school is worth briefly mentioning, and this was Bion of Abdera. Bion argued that there were parts of the Earth where it was day for 6 months and night for 6 months. Sadly, only a single line from Bion of Abdera's life survives, and it's in Diogenes Laertius's Lives of the Eminent Philosophers, and it basically just says that. Actually, Diogenes Laertius was writing a chapter on an entirely different person who just happened to be named Bion, but at the end of his chapter notes that there were also 10 other philosophers named Bion, and gives a one-sentence description of each of them. So that is all that is survived of Democritus' student Bion of Abdera. But Leucippus and Democritus influenced philosophers who made greater names for themselves than poor Bion of Abdera, even though these philosophers founded their own schools. The best known of these was Epicurus, who adopted many of the elements of atomic theory, but his philosophy was so distinct that it is classified into its own school, the Epicurean school. Epicurus, of course, was hugely influential both in his day and our own, and is well enough known today to have inspired the adjective Epicurean, although the modern usage of the word is only loosely related to Epicurus's original philosophy. But Epicurus was largely interested in how to live the good life. He did not have much time for traditional philosophical subjects like epistemology, or even, I'm sad to say, astronomy. Apparently, he even banned the study of logic and rhetoric in his school. Since he had little to say about astronomy, I will return the favor and say little about him. Well, the last thing I'll say about atomic theory, at least in this episode, is with regard to a cross-cultural connection, which I hope to say more about in a future episode. Earlier, I had mentioned that there were tales of Democritus traveling all the way to India and learning from the so-called naked philosophers. This trope of the naked philosopher in the East actually occurs in a number of places in Greek texts. The Greeks even had a word for them, the gymnosophists. It probably had some basis in reality, although which sect or school it was about is not entirely clear. It may have been in reference to the monks of the Digambara school of Jainism, since they practiced a very severe asceticism, which sometimes included giving away all their possessions, including their clothes. Now, whether or not Democritus had made it that far east is unknown, and on the whole probably unlikely, but there's an intriguing connection to some of the natural philosophy that developed over in India around this time. In particular, there's an ancient Indian text known as the Vaisesika Sutra, which puts forward a natural philosophy that's largely in agreement with the natural philosophy of both Empedocles and Democritus. The text holds that there are 4 fundamental elements, and that these are identical to the 4 classical elements in the West, with the exception that it takes light to be an element rather than fire. And what's more, the text also adopts an atomic theory, and states that these 4 elements only appear in a finite number of atoms. Now, frustratingly, there's a pretty big uncertainty in the date for this text. It could have been authored anywhere between the 6th and 2nd century BC, although recent scholarship has favored the later dates. If it is on the later side, then it would have been written well after the time of Democritus and Leucippus, and couldn't have influenced them. But the earlier date at least opens the possibility that some of these ideas were not original to ancient Greece. And regardless, it's important to note that even if the text was written later, it may have been derived from oral traditions which were even older. We tend to view the ancient world through the lens of individual empires. We look at ancient Babylon or ancient Egypt or ancient Greece, and we maybe talk about their wars with each other, but particularly after the recovery from the late Bronze Age collapse, people traveled far and wide in the ancient world, and even if they individually did not span the entire Eurasian continent, chains of trade and exchange did. So tales and ideas made their way to far-off lands. And even if the tales were tall and the ideas strange and distorted ideas can still have impacts in new lands. All of this is to say that we really can never treat these civilizations of the ancient world in isolation from one another. They all influenced each other, sometimes across large distances, and teasing apart which ideas are truly original to which civilization can be a difficult or even impossible task. Well, for the past 5 episodes, I've been telling you about the astronomy of a number of ancient Greek philosophers who, at the beginning of this episode, I told you are scandalously lumped together as the pre-Socratic philosophers. But in the next episode, we will finally cross that threshold out from pre-Socratic philosophy and into the world of philosophy in Athens after Socrates, where we will look at the astronomy of a philosopher who would be of titanic influence in Western thought for centuries, Plato. I hope you'll join me then. Until the next full moon, good night and clear skies.